Our next speakers are Rory Macneil of RSpace and Astudillo of Surf. And their talk is entitled RSpace, iRODS Integration, Update, and Next Steps. Take it away.
Great. Thank you, Corey. I'm going to start. Thank you, Rory, for inviting me to this introductory part of your session. So the question is, I got invited because we've been talking for a while now. RSpace is doing lots of things, also in combination with colleagues here in the Netherlands. And at some point, we were inspired by talks that we were having from in the imaging group, possibly about integrating Omero, heard in the past. So this got me thinking, what happens when multiple pieces of software thought of in a different way will eventually have to handle the same data or work on the same data or discuss, modify, change, right? So this is basically what we're going to go through today. And these were the conversations that we were having, Rory and I. This is how we usually look at a data management platform based on iRODS. From the bottom up, storage. On top of storage, you've got something that knows how to talk to storage, that exposes it to the iRODS server. And then on top of that, you've got interfaces. And on top of that, you've got different kinds of users with different roles, including the little robot there tries to say automation can happen externally from and to the data management platform. So picking up where I started, what if we, in Spanish, we say you take a sock and you turn it inside out? This is a different representation of what's there. So basically users, the data is in the center. That's the main thing. You put it in the data management platform. And then what? Well, I just came up with this way of trying to showcase that policy steers can steer what you cannot do with the data. Guess what? iRODS can help you steer the policy and the data. And in the outer rim, from the outside, you've got apps. For example, Yoda is one of, for lack of a better name, I'm calling an app here. You've got different parts of Yoda working together within the data. But that cannot be enough. If you're looking at doing things with the data, you're not only managing it, you're processing it, you're changing it, you're adding it, you're creating it. So other apps need to work together. This is the idea. Omero, as I explained, is another example. And what can come next? If you start generalizing this, how are you going to work? How are you going to make sure that apps are good citizens to each other in this landscape? Well, the answer is coming up in the next slides.
Thanks, Ander. Hi, everyone. So thanks, Ander. Yes, so answer to the question of how you're going to make this work is in the context of research commons, which I think are becoming very important. So there's lots of definitions of research commons. My favorite one, which I think is in a way another way of articulating what Ander just described, is Scott Yokel at Harvard University, who says a research commons brings together data with cloud computing infrastructure and commonly used software, services, and applications for managing, analyzing, and sharing data to create an interoperable, and I think that's an important word resource for a research community. So last year, some may be familiar, many may not be familiar, the RDA Global Open Research Commons Working Group created what is rapidly becoming a very popular model for creating global open research commons, and there are 9 elements to it. The blue ones at the bottom are the kind of the hard elements. The white ones are kind of the soft human elements, and the services and tools elements are what's particularly relevant to us. So here are a couple of examples of research commons. What does this actually mean? The first is a proposed Norwegian research commons, which was the first ever research commons to be based on the GORC model. And you can see again is quite familiar to Anders' model. So you have storage at the bottom, and then you have iRODS as a broker, And then critically, the notion of the research data lifecycle comes in. So you have research data lifecycle built on this structure, which goes from plan to prepare, collect and process, share and reuse, and then publish. And you have a bunch of what he referred to as apps, including and some of the apps are already interoperable, like DMP tools in RSpace and Dataverse. You can already pass data and metadata between them, but most of them are not. A second example is the Harvard Data Connect. If you just looked at the bottom thing, forget the top stuff, that's kind of the white stuff, but actually it resonates quite a lot with the Norwegian Research Commons, and it was put together by different people as well. So key issues in this emerging Research Commons model are two forms of interoperability. One is the interoperability between the storage and the apps, where iRODS clearly has a role to play. And the other is the interoperability between the apps. So that, for those who aren't familiar, RSpace has started out life as an electronic lab notebook. We still have an electronic lab notebook. Then we added a physical sample management system. And then basically kind of becoming obsessed with interoperability, we connected with an ecosystem of research tools and research data management tools. The research data management tools are in purple, research data management plans and repositories, so you can let data pass between them using RSpace. And then at the bottom are more specialized tools, including, importantly, Omiro and iRODS. So I'm not really going to talk too much about this today because there's no time. But it's really an ecosystem of tools. The ecosystem has overtaken the individual tool. And iRODS is a platform for furthering that process in ways which bring together different tools in the way that Ander alluded to. So that brings me to the next portion of the talk, which is to talk about our integration with iRODS. And stage one of the integration was already done last year. And this basically enables administration of connections. So iRODS sits between RSpace and the storage. And when you make links to files that are in the storage, iRODS tracks the links and it solves the broken links problem. So I'm just going to go through these quickly. And then also when you can also, part of this workflow is when you link to a file in an RSpace document, you can then export, when an export is made from RSpace, say to a repository, you can pluck the linked document and it can be sent as well, which is an example of interoperability. All right, so the second stage we have just completed, and we're going to play a short video. If I advance it, it'll work. Okay.
This is a brief overview of the iRODS integration in RSpace. RSpace is a digital research data management platform for the active research phase. It features an electronic laboratory notebook and a sample management system. RSpace integrates with a wide variety of research and data management tools across the entire research data lifecycle. To enable iRODS manage file stores in RSpace, an administrator needs to configure iRODS as a file store for their RSpace instance. As soon as the connection details are provided in the System Configuration menu for institutional file systems, iRODS becomes available for RSpace users. Once set up by the RSpace administrator, RSpace users can add specific locations on their institutional file systems for convenient access in the RSpace gallery. The RSpace gallery provides access to all files uploaded to RSpace, as well as access to remote file stores. After authorizing themselves for their institutional file system, RSpace users can access and download the contents of the given remote storage location from the gallery and create links in their electronic laboratory notebook. For example, when documenting their research, researchers either attach files from their local machine to their electronic notebook, or they can create links to specific items in an institutional file system. In the case of iRODS, these links utilize iRODS file identifiers to ensure that links don't break and continue to work, even when the file has been moved to another physical location managed by iRODS. Such file store links are also taken into account when researchers export their RSpace documents either locally or to a repository. In the export flow, they can choose whether to include the linked files in the export and ensure their availability. The files linked in the corresponding documents are then fetched from the remote location and included in the export bundle. Since RSpace version 1.99, we've added further functionality to allow RSpace users to move or copy files from RSpace to iRODS. When a researcher documents an experiment in RSpace, they often add files such as images or data from their local machine to their RSpace documents. These files can be then found in the gallery along with their RSpace metadata. After selecting one or more files from the RSpace gallery, RSpace users can click on the Move to iRODS button to open a dialog in which they can specify where to move or copy the corresponding files to and authenticate themselves on their iRODS server. Users can choose to retain a copy of the corresponding file in RSpace. Once authorized, the files are transferred. This new functionality allows RSpace users to store any research data they collect in RSpace in their institution's file store system for archiving or sharing with users outside of their RSpace instance.
Okay, so that's the move to iRODS we've just added, and now things are going to get a lot more interesting. So I'm going to tell you who gave us this idea, really, and thanks to him in a minute. But we now have, thinking more ambitiously perhaps, of RSpace as a front end for iRODS that will enable researchers to seamlessly work with internal and externalized files by efficient RSpace workflows that synchronize metadata and maintain provenance information. So what does this mean exactly? Well, we thank you to Sam Ely, who's a PI at KU Leuven, who uses RSpace and is keen to do more with iRODS. And he articulated this, that it would be of much interest to us if the RSpace gallery could act as a front end for iRODS to allow upload of data to iRODS, possibly even defaulting to storage in iRODS. To allow retrieval of data from the iRODS interface outside of RSpace, it would be good if RSpace were to update a specific metadata field in the iRODS catalog when files are linked to experiment entries in RSpace, so that querying the metadata catalog for a particular document identifier could retrieve all data associated with that document. So this really got us thinking. And we're now planning stage 3 and stage 4 of the integration, which I think is going to really kind of be take us to the next level. So stage 3 involves better metadata exchange. And so provenance, preserving links and version history between RSpace documents and externalized research data, and also discoverability, finding and accessing content in iRODS and RSpace via RSpace managed tags, ontologies, custom tags, and document IDs, forms, and templates. So that's stage 3. And Thilo is actually leading this work. It's going to involve a number of things. We're looking at different metadata schema exploration, and one thing which we're kind of focusing on, which would be interesting to hear if others, is RO-Crate, which seems to becoming a more and more popular metadata exchange format in a variety of contexts. And we're actually working with Leiden University. Some folks from Leiden are here today to explore particular use cases in this metadata exchange. And so then stage 4 is really moving beyond that to become a universal front end for iRODS. And the metadata exchange we are working on at the moment, and we should be completed by Q3. And then in Q4, we'll begin to look in more detail at front-end usability. So what does this involve? Well, it involves the gallery is where we store files in RSpace. So improving the RSpace gallery workflow, including things like direct uploads to iRODS, more convenience like drag and drop, and also the ability to search an iRODS file store from within RSpace. And then beyond that, further functional improvements, which we still need to spec out in more detail, but in particular, things like active management workflows for iRODS files and metadata from within RSpace, and then ultimately using iRODS as a default file store for RSpace. So coming back to the big picture of the research commons, in principle, this will allow iRODS to realize more of the vision that you saw in those kind of the Harvard and the Norwegian examples, which is to become a core part, in fact, kind of the operating hub in some ways of a research infrastructure, both for institutions and for research commons and research clouds. So that's kind of the, that was the end of the original talk, but then we have one more slide, which is we started thinking about Yoda because, as Anders said, we need to think about Yoda in an iRODS universe. And conveniently, Fabian Monheim, who's at the Leibniz Institute for Aging, which already uses RSpace, is using iRODS and is beginning to implement Yoda, gave us a possible workflow where one workflow which would be useful to have an iRODS, to have an RSpace Yoda connection, which is really dealing with metadata. So this Fabian couldn't be here, but here's the workflow he described. So a researcher selects data to add to documentation in RSpace. The data is uploaded directly to iRODS at the same time for storage and discoverability. The metadata of the RSpace document itself is also passed to iRODS. And then, and here's the Yoda metadata, for example, the epic is then passed back to RSpace along with the iRODS file ID, and the RSpace document receives links to data on iRODS. So that's a workflow which Fabian thinks would be useful. And with that, I'm going to pass over to Thilo to tell you about our other news.
Thanks, Rory. Now for something completely different, but related to how we envision working with institutions and individual contributors in the RDM community. We're going open source. You may have heard of this already, but now we have a date and it's June 26th, so soon. RSpace will be entirely released under HPL 3. Research space, we will remain the maintainer of the project using GitHub, where you can also find like all further information about the project, and we'll continue to provide services for research institutions to implement, adopt, and maintain RSpace. Obviously, going open source will make our approach to product development even easier. We always collaborated with institutional partners and customers. So now we have an opportunity to even more conveniently co-develop solutions with customers and partners. And some of them you have heard already. Fabian Monheim is a collaborator in Germany that we work with. Leiden University was mentioned. Also a shout out to Leonardo, who is there he is, hello, who will potentially be our first contributor to the open source project. We're also working with TU Delft and many more, right? So besides these collaborations, we're also open for individual contributions. This can be ideas that you can share with the project, feedback and experiences, code contributions, obviously, and also like helping others using RSpace. Yeah, we're super excited to work with you all on that. And last but not least, if you want to follow the project, we have an open source community mailing list already. You can just sign up to that if you're interested. Everything else will be on our GitHub page, which is linked here. And you can also follow our news on our blog. And of course, reach out if you have any questions directly to me or Rory. Thanks.
Do we have any questions? No questions. All right. Do we have any in the virtual Slack, in the Slack channel? Okay. Well, they'll be here at the conference. So if you do think of questions, then feel free to come find them.